The National Electrical Code, or NEC, prohibits running electrical conductors in the same raceway as piping containing water according to Article 300.5. SDR35 PVC conduit is not approved for electrical use. Water penetration into the electrical conduit can cause short circuits or electrocution hazards. The PVC conduit may not provide sufficient protection for the feeder cable from moisture, which can lead to insulation failure. The presence of water in the conduit can accelerate corrosion of electrical connectors and components. Accessing and repairing the electrical feeder or water line would be more challenging in a combined conduit. This installation may not pass building inspections or electrical safety certifications. It is recommended to separate the water line and the electrical feeder into separate conduits. Use appropriate conduit types for each. SDR35 for water and Schedule 40 PVC for electrical. Ensure there is no water penetration into the electrical conduit by properly sealing all connections. Have the installation inspected by a qualified electrician to ensure compliance with code requirements. The cable sheathing is not typically used for underground installations. It is recommended to use direct buried cable for this purpose. Running conduit across a creek may require additional protection measures, such as encasing the conduit in concrete or using a larger diameter pipe to allow for more slack. Firstly, there are electrical code violations. The National Electrical Code, or NEC, specifically prohibits running electrical conductors and water pipes within the same raceway. This regulation exists to prevent potential hazards and ensure safety. Article 300.5 of the NEC clearly outlines these restrictions. The NEC is a comprehensive set of standards designed to safeguard electrical installations and protect people and property from electrical hazards. Secondly, SDR35 PVC conduit is not approved for electrical use. This type of conduit is typically used for drain, waste, and vent, or DWV applications, and it does not meet the requirements for electrical conduit. Electrical conduits need to be rated and listed for electrical use, ensuring they can withstand the stresses and conditions associated with electrical wiring. Thirdly, there are significant safety hazards. Water and electricity are a dangerous combination. If water penetrates the electrical conduit, it can lead to short circuits, ground faults, and electrocution hazards. The risk of electrical shock is greatly increased when water is present in the same conduit as electrical conductors. Fourthly, water damage is a major concern. Water penetration into the electrical conduit can cause extensive damage to the electrical system. This can result in costly repairs and potentially dangerous situations. Protecting electrical systems from water damage is crucial for maintaining their integrity and safety. Fifthly, cable insulation failure can occur. The PVC conduit may not provide adequate protection for the feeder cable from moisture. Over time, moisture can degrade the insulation of the electrical cables, leading to insulation failure and potential electrical hazards. The quality and type of conduit used play a significant role in protecting the cable insulation. Sixthly, corrosion of electrical components can accelerate. The presence of water in the conduit can accelerate the corrosion of electrical connectors, terminals, and other electrical components. Corrosion can compromise the integrity of these components and lead to system failures. Corrosion-resistant materials and proper sealing techniques are essential for preventing this issue. Seventhly, maintenance difficulties will arise. Accessing and repairing either the electrical feeder or the water line becomes much more challenging when they are combined in the same conduit. Maintenance work may require shutting down both the water and electrical systems, causing inconvenience and potential disruptions. Separating these systems simplifies maintenance and reduces the risk of damage. Eighthly, there will be compliance issues. This type of installation is unlikely to pass building inspections or electrical safety certifications. Building inspectors and electrical authorities enforce the NEC and other codes to ensure that installations meet safety standards. Failure to comply with these codes can result in fines, rework, and potential liability. Recommended actions to rectify this situation are as follows. 1. Separate the water line and the electrical feeder into separate conduits. This is the most fundamental step to address the code violations and safety concerns. By physically separating the two systems, you eliminate the risk of water and electricity coming into contact. 2. Use appropriate conduit types for each system. Use SDR35 conduit for the water line and Schedule 40 PVC conduit for the electrical feeder. Schedule 40 PVC conduit is specifically designed and rated for electrical applications. 3. Ensure there is no water penetration into the electrical conduit. Properly seal all connections and fittings to prevent water from entering the conduit. Use watertight connectors and sealant to maintain a dry environment inside the conduit. 4. Have the installation inspected by a qualified electrician. A professional electrician can verify that the installation complies with all applicable codes and standards. They can also identify any potential issues that may not be immediately apparent. Additional notes to consider are the following. Standard electrical, or C, cable is not typically used for direct burial applications. It is recommended to use direct burial rated cable for underground installations. Direct burial cable is designed to withstand the harsh conditions of being buried underground, including moisture, soil acidity, and physical stress. Running conduit across a creek may require additional protection measures. Consider encasing the conduit in concrete or using a larger diameter pipe to allow for more slack. These measures can help protect the conduit from physical damage and ensure its longevity. In summary, the installation described poses several significant problems due to electrical code violations, safety hazards, and potential damage to the electrical system. To rectify these issues, it is essential to separate the water line and electrical feeder into separate conduits. Use the appropriate conduit types for each system, ensure proper sealing to prevent water penetration, and have the installation inspected by a qualified electrician. Following these recommendations will ensure a safe and compliant electrical installation. Furthermore, the selection of appropriate materials is critical in ensuring the safety and longevity of any electrical installation, particularly when dealing with underground wiring. Firstly, understanding the different types of cables and their intended applications is paramount. Standard electrical, or C, cable, while commonly used for above-ground wiring, is not designed to withstand the harsh conditions associated with direct burial. The cable's outer jacket is not sufficiently robust to protect the conductors from moisture, soil acidity, and physical damage, which can lead to premature failure and potential safety hazards. Secondly, direct burial, or DB, cable is specifically engineered for underground installations. This type of cable features a rugged, moisture-resistant outer jacket that provides superior protection against environmental factors. The conductors within the cable are also insulated with materials that are resistant to degradation in wet or corrosive soils. Using direct burial cable ensures that the electrical system remains safe and reliable over the long term. Thirdly, selecting the appropriate conduit is also crucial for protecting underground wiring. While Schedule 40 PVC conduit is commonly used for electrical applications, it may not always be the best choice for installations that are exposed to water or physical stress. In situations where the conduit is run across a creek or in areas with heavy traffic, additional protection measures may be necessary. Fourthly, encasing the conduit in concrete provides an extra layer of protection against physical damage. Concrete is a strong, durable material that can withstand the forces of nature and human activity. By encasing the conduit in concrete, you can prevent it from being crushed or damaged by heavy objects, such as vehicles or fallen trees. Fifthly, using a larger diameter pipe can also help to protect the conduit and the wiring within it. A larger pipe provides more room for the wires to move and flex, which can reduce the risk of damage from stress or strain. Additionally, a larger pipe allows for more slack in the wiring, which can be helpful when making repairs or modifications to the system. Sixthly, proper sealing techniques are essential for preventing water from entering the conduit. Water can cause corrosion and damage to electrical components, leading to system failures and potential safety hazards. To prevent water penetration, all connections and fittings should be sealed with watertight connectors and sealant. These materials are designed to create a barrier that prevents water from entering the conduit, even in wet or submerged conditions. Seventhly, regular inspections are also important for maintaining the safety and reliability of underground electrical systems. Inspections can help to identify potential problems before they become serious, such as damaged conduit, corroded connections, or water penetration. By addressing these issues promptly, you can prevent system failures and ensure the safety of your property. Eighthly, working with a qualified electrician is essential for any electrical installation, particularly those involving underground wiring. A qualified electrician has the knowledge, skills, and experience to ensure that the installation is done safely and correctly. They can also help you to select the appropriate materials and techniques for your specific situation. Ninthly, understanding local codes and regulations is also important for ensuring compliance and safety. Local codes and regulations may vary depending on your location, so it is essential to check with your local authorities to ensure that you are following all applicable rules. Compliance with local codes and regulations is not only a legal requirement, but also a way to ensure the safety of your property and the people who live or work there. In addition to the above considerations, it is also important to consider the potential for future expansion or modification of the electrical system. When designing the underground wiring, it is wise to allow for some extra capacity to accommodate future needs. This may involve installing larger conduits or running additional wires. By planning for the future, you can avoid the need for costly and disruptive upgrades later on. Finally, proper documentation of the electrical system is essential for future maintenance and repairs. This documentation should include a detailed diagram of the wiring, as well as information about the materials used and the installation techniques employed. By keeping accurate records of the electrical system, you can make it easier to troubleshoot problems and perform repairs in the future. In summary, ensuring the safety and reliability of underground electrical systems requires careful planning, the selection of appropriate materials, and adherence to best practices. By following these guidelines, you can protect your property and the people who live or work there from the hazards of electricity.